(6169)?
Correct.
Okay.
69 to 78.
All right, let me ask. What'd you do first, Nate?
Well, the first thing I did was I put my lines to group it.
Okay, cool. Let's do it.
What section is this?
This is 6.1. So somebody else sees something else you could do. We're going to do that at the end. So don't worry, we'll get it. We could, but we're going to do this. What comes out of these two?
6.
Minus 4.
I like it. So then you know what you got to take out to make this a Y. What do you got to take out? Cool. Is that cool? Is that what you did?
Yeah.
All right. And then what do you get inside?
Y4. Y minus 4, sorry.
I like it because the sign changes here, right? So then the almost last step.
It would be Y minus 4, parentheses, 6Y3 minus 2Y.
So if you stop there, why is that not quite right?
I don't know.
You can still go down from the 2.
Get a Y out of it.
Yeah, out of this I can take a Y and a 2. So if I put a 2Y out there, what's left here?
3Y.
Minus 1.
I like it. There you go. So from the very beginning, somebody pointed out you can take a 2Y out because everything has a 2 and everything has a Y. You see that?
Because the right section is still as a DCF.
So it doesn't matter if you take it out first, if you take it out last, just don't forget to take it out. The reason I wanted to do this is because I noticed in the few people's homework that I've graded so far, they stopped here. You know you're done when nothing else can be done with any piece. You know, it's exactly like if I ask you to factor 24 all the way and you say 2 times 12, no, 12 goes further, right? Yeah.
How do you know to put the 2Y in front of the Y4? Y minus 4.
Do it. Oh, all right. Let me show you something. So if I put Y minus 4 and then I took a 2Y out and then I put my 3Y squared minus 1.
Okay.
Does that look right? Yeah.
Right.
So that we just normally take any monomial, we make it into the coefficient. We just bring it all the way out front. Cool. I like it. So that's what I'm really doing, but that just looks weird. If you wrote that, I couldn't say it's wrong. I would just say, well, that looks weird. Don't do that. All right. I like it. Cool. All right. So yeah, you do take that out front. Sure. Anything else from homework stuff?
Yeah.
60? Oh, okay. This is sort of like this one in one respect.
I started, but I feel like I forgot how to do it, so I skipped out doing it.
Nice. All right, so we got what they want from this year? Okay. So now we're in 6.2, number 60. What's it? 2 x squared. Now, two things going on here. We just learned the other day about what to do when there's a number that's not 1 out here. this is not in the section where you're supposed to know that yet. So that seems a little evil, but at the same time, it's a major hint. Can I make it so that there's only a 1 here? Yeah, because what can I take out? 2. So the 2 is what's making this a harder problem. The great thing is I can get it out of the freaking way. So if I take a 2 out, what am I left with?
X2 plus 4x.
Times 5.
And now this, I try to factor. Again, you're not done until every piece is done. And that piece might not be done. It's got 3 terms. What can I try to do? First number is a 1.
Oh,
What am I looking for now?
something that multiplies the negative 5 times the 4.
Exactly. And the only things that multiply by 5 are
1 and 5.
1 and 5, and they make a positive 4 if
Oh, yeah.
Negative
5 has got to be
negative
positive. So then how can I write these?
2x2.
plus 5
Never mind.
x minus 1.
So you got the 2 out of the way. So notice how the minute it's out here, it just keeps, if there were more steps, it would just keep coming for the ride. I'm here, I'm here. Don't lose him. Don't let him fall over the cliff. No, 2. So he's there, and now I'm just taking this guy and rewriting him. Just like again, if I said factor 24 and you said it's 2 times 12, and then you started breaking him up, that 2 is still there, right? It's going to be in your answer. You don't want to lose it. Because then you would be wrong, and that sucks to be wrong. Okay, maybe. Would it work if you did 2 times negative 10? Of course it would. It would. You would just end up with like 2x plus 10, so you could take a 2 out, and you'd end up in the same place we just did. It's just easier to take it out in the first place. All right. Anything else from homework?
Number 4. Number 4.
In 6-2? 6-2. Oh, the one about if it can't be factored?
Number 6-3.
6-3. All right. Oh, yeah. It's almost hard when they do some of the work for you. So on number 4, 6-3. Where'd you go? There you go. I think they start you off with 3x and 2, x and 1. So one reason they do this is just to see if you're able to think ahead. What do I know has got to be true about these? Can they be the same sign?
No.
Why not? Why can't they be the same sign?
Because you have a -2.
Yeah, it's got to multiply by negatives. One has got to be negative. The thing you've got to realize is, whatever, if I put a minus here, that makes this minus 3x. So what's got to be, I'm going to get a 3x and a 2x to get my middle term. Let me stop right there. Does everybody understand what I'm talking about? How do I get the first term? 3x times x. Check. How do I get the last term? 2 times 1. Okay, but I got to figure out the sign out. So how do I get the middle term? The mixed terms in the middle. So to make it minus x, does 3x have to be negative? Or does 2x have to be negative?
3x.
Yeah, 3x has to be negative. So to make 3x negative, I have to make
-1.
that negative. So that's why I like those problems. They're forcing you to think about where would this come from, and let me make that work. Now the way we do it, we don't have to worry about that really, because grouping makes it all kind of fall in the right place. Yes, sir.
But when you would, oh wait, never mind.
It's freaky because this guy mixes with this guy. So if you want him to end up negative, you got to put the negative there. That's the way that's going to work. What's up? So you got to think about what the next step would be. You can't just stare. You actually have to think. Well, 3x squared is there, 2 is there. Where would the negative x come from? This and this. That's how you figure out who's negative, who's positive. To make this work in the middle. Sure. What about?
Can you do number 35?
Or are you still doing one?
Well, we're gonna do one more like this. Let's see. All of these are sort of the same, really.
I think like they're the same problems on the next section. I was going to ask you. I just didn't bring my book. With an actual problem, a different problem.
Sure. Let's do this first.
Okay.
This last one?
Oh, yeah, that.
So what's 16? We had a
2. Oh, 3. 2 is another. All right. Same thought process. So first thing I realized is that they have to be, yeah, good, the same sign, and they have to be positive. So this is almost, I mean, this was too easy. The only difficulty comes when it can be negative, and I got to figure out which one's negative. Yeah. And really what you can do is just put plus minus on the last one we just did, and then check. And then like, oh shit, this got to be the other way around. I mean, it's really that simple. You just put them somewhere, you check. If it doesn't work, well, guess what? They should have been the other way. Some of you guys are physically here, but I haven't quite mentally caught up. I did. I'm just happy that I'm sitting here right now. I think, unless this is a dream. All right. Who did I skip over? Yeah.
35.
In 6-3?
Yeah.
Okay. 35's got some gross looking numbers. Let's see. Right? Because is there anything that comes out of all three numbers? Damn. It's too damn bad. So you got to do 24 times 12.
That's one.
What's 12 times 12?
144.
That's twice. So what's twice 144? 288. I like it. So negative 288. And I need factors of negative 288 that add up to be negative 23. So maybe you guys are starting to buy into my other approach here. I don't want to do that. Right? So what I start with then is, what's got to be true about the two numbers?
You gotta add 20.
But what about the two numbers themselves? Are they both the same sign?
No.
Okay, I really want this to make sense. I know they have to be different signs. So when I'm thinking about what adds to be 23, I can't just say 7 and 16, because if they're different signs, they're not going to make 23. They're going to make 9 or negative 9, right? So they got to subtract to be 23. So like, let me start this off. What's the easiest way to make 23? 30 and 7 maybe. If the 30 is negative, does that make negative 23?
Yes.
Yes. But what's 30 times 7? 210. All right, 3 times 7 is 21 with a 0 on the end. Is that what I want? Is it too big or too small?
Too small.
All right, Price is Right time. So if I go up to negative 32, what goes here to make it become negative 23 when I add it?
9.
You can do it. So if that goes up by 2, that's got to go up by 2. Do you see? That's kind of nice. I know this is like playing with numbers, but that's basically a lot of math just boils down to playing with patterns in numbers. That's what it really is. So when you multiply those, what do you get?
288.
Oh, shit. All right. Sorry. I didn't even know. I didn't know yet until I did. All right. And you can cut this down. I know that's not going to work because it's going to end in a 0. You guys see? And I don't want it to end in. I want it to end in an 8. That's why this has got a good chance of working. So there's a lot of ways you can kind of make this quicker too. You can start with a better guess than this. This guess sucks. They got it started, but I know it ended in 0. I don't know if you guys. The better you are just playing with numbers, the easier that's going to be. Now the other way to do it is just to start. Well, this is 144 times 2. No. This is 72 times 4. No. But real quick, do you see how I just did that? What's half of 144?
72.
And what's twice 2? 4. So I can play with the factors like that. If I take half of this guy, I can put 2 on that side. So overall, they still multiply to be the same thing. Do you guys see that? So that's another thing that you can do. Just play with a factorization. Just move parts of it around. That don't work, so I can try to cut it in half again. 36 and 8. That doesn't make 288, right? Yeah, okay. I mean, when it makes 20, it doesn't make 23. And then you can just keep going until you get here, right? There's a lot of different approaches you can take to this, is what I'm trying to say. You don't have to just make a list of factors out of nowhere and just pray that you hit the right one. There are ways to make it more systematic. Maybe. So okay. Now let go of it, Jeff. You got your two numbers. What the hell do I do with these two numbers? What do I do with these? Can I just do like this? M minus 32, n plus 9.
No.
And I'm done. Yay, me. I got the numbers, I put them in, what's wrong? How would you tell somebody they were wrong? How would you explain to somebody that this is wrong?
You're wrong.
That's awesome. See, this is why, maybe, if you want to be a teacher, work on it. If you don't want to be, that's good. Don't. What's a quick way to show somebody they're wrong here? What's supposed to be true about this? When you do what, it's supposed to what? When you multiply, it's supposed to become this. Very quickly, what is m times m? Is that what you want? So if they still don't agree with you, you're like, I can't work with you. I don't know. M times m is not 24m squared. How could this possibly be the answer? Do you guys get that? I'm spending a little time on this because this is the most common mistake. People get here and you're like, well, that took enough work. I must be done. No, you ain't done yet. Shit. All that was to find the numbers to do what with?
Fill in for 20.
Negative 20.
Yeah, rewrite this. So it'd be 24m squared minus 32
Plus
M
m
plus 9.
plus 9m.
minus 12.
So this is here. Why am I allowed to do that? Because I can rewrite 23, negative 23 is negative 32 plus 9 anywhere in the universe I want to. I can do it. Normally I wouldn't. Here it helps me. So of course I will. Right? Because now I can do it.
Now you're back.
So out comes,
8.
yeah, 8 can come out. And real quick, do you guys remember, like, what's the difference between 32 and 24? How far apart are they? 8. So 8 might be a good choice to work with, or factors of 8. 8 does happen to come out, and what else? M.
M3.
3. M.
Minus 4.
4. I like it. So I know I want,
3.
what comes out? 3 to make it 3. M minus 4. Okay, let me stop there for a second. So some of you guys, I think you hate factor because you feel like you're kind of floating and it's like, just guess and pray. No. If you think that's what it is, it's not right. There are constraints. There are ways to make it quicker. You know what numbers, you know what you want them to do. There are other ways to get them to do what you want them to do. So at the end I can write 8. All right, 8m plus 3?
3m minus 4.
3 minus 4. Or the other way around, doesn't matter. Because it's multiplication. Multiplication doesn't care. Yeah. There. All right.
I have a question.
Yes.
The question, the 4, 6, 3. The rule said when you have minus, we can go to the minus plus. But here it's different. So we can.
All right. So you got to be careful. It sounded to me like you're saying the rule always says if you have minus, then you can write in the answer minus plus.
Okay.
That's not what the rule says because the answer can be written either like this or the other way around. So it really just depends on if the middle number is negative, you want the bigger number to be negative, right?
Yeah.
That's what tells you where the negative sign goes. Yeah. Okay. Just to bring this up again. For the semester, most of you guys have been pretty good with homework. I'm still way behind on getting homework from some of you guys. I'm a little tiny bit concerned about that. So, quiz tomorrow. even if you're in chapter 5, I would highly suggest go do some of that homework so you're ready for the quiz tomorrow. That's basically what you always do, right? You work with the reality of where you are in the homework with the reality of what the hell I'm doing to you the next day. Cool, I like it. You gotta get the practice, especially with factoring. Good God. Yeah.
Is long division gonna be on the test?
On the test, yes. Not on the quiz tomorrow.
Not sure.
I'm trying to give you guys time to work that out. I don't know. All right, how we doing?
I'm just asking to do 161. I just wanted to know.
What's up?
Apparently I did everything. Can we just do 24?
Oh. So guys,
6-1.
watch this. I haven't had enough homework to see where the common mistakes are, but once you learn what we just did, I get people that do this. They try to factor this like this. Now tell me, if you saw somebody who wrote that down, how would you stop them and convince them to not go the direction they're going in?
You're wrong. There's only 2 terms.
There's 2 terms. That's one thing. Now, today we're going to learn that there are some 2-term deals that we can do this with. Oh, shit. But right now, you'd say there's only 2 terms. There's not 3, so you don't want to start
Well,
there.
you started with addition, subtraction, and now you have.
Yeah, because what do you always try first? GCF. And GCF means take a monomial out. If they really want to be hyper-technical, right? We take a monomial out. So really what I'm going to have is this. I'm going to put my GCF here, 4m squared, and then I put the result. I like it. So I think sometimes when we learn this, you try to do this with everything. Oh shit, no, can't possibly work, right? I like it. You guys okay with that? Sometimes when I explain a mistake, you're like, I never thought of that, and now I'm going to do that. Oh shit, no.
Can you, the 4M, how did you get the 2 on top? I'm confused.
Oh, how many M's does this guy have?
3,
3. How many M's does this guy have?
2,
How many do they have in common?
2.
There you go. The shortcut is I always take out the lowest power on the variable I see because that's the amount that they all have in common.
And then the M minus 2 is because of 4.
Yeah, if I divide this by this, I'm left with just an M.
Okay.
This divided by this, I'm left with just the 2. Because those 2 M's came out.
Okay.
I like it. So please embrace GCF. Let GCF be your friend. Like, oh, it's a GCF problem. Well, thank God. Yeah.
Problem number 6.1 or 6.2. Problem number 15.
Oh,
That's just prime.
no. This one's a little bit weird, but what are the only 2 numbers that multiply before and add to before?
Well, so I was thinking that. So we can do 2 squared instead of 4.
Well, no, it'll be, okay, you can look at it as 2 squared, but what multiplies before and adds to before? 2 and 2. So then I'm done. What do I put down here?
Oh, so we're just pulling out. Okay, I guess.
Just because of the same doesn't mean it's a different process. You just happen to have a 2 and another 2.
But where is 2 from the y squared?
How do you get y squared? What times what is y squared? Y times y.
But because they don't all have a GCF,
Yeah, I can't take a 2 out. I didn't take a 2 out. I didn't say this is equal to 2 times something. I didn't do that. Because this guy didn't have a 2.
Okay.
Yeah, I wrote y squared is y times y. 4 is 2 times 2. And 2y and 2y is 4y. Bam. Everything balances.
How do you get the y?
Here?
Yeah.
Or where?
The regular y.
This one?
Yeah.
So 4 is 2 times 2, right?
Uh-huh.
Y squared is...
Y times y.
Okay, done. I'm just breaking them up. Do you see that? Because what did we just do? If I had x squared, we just did this one earlier. What was it, Jeff? You could do it. Can you do it, Jeff? I can't remember. Yeah, I think it was this here. We did that one earlier.
Yeah.
Yeah.
You need the two numbers that multiply negative 5 and make 4. Well, that'd be 5 and 1. And then how do you write the answer? X plus 5, x minus 1. Why does that work? Because x times x is x squared.
Yeah, I'm talking about like the y by itself. Like the y out there.
Here.
No, up top.
Where's there? This is the problem.
That's okay, never mind. Actually, yeah, that's a 4.
Okay, I see.
Okay, yeah. I was
Yeah,
like,
4s and y's are a horrible combination.
Yeah.
I'm sorry. Thank you.
Yeah.
All right.
Thanks.
So it's 6-1 is back there, it's just y plus 2, y plus 6.
Yes. And some of you guys might realize this is beautiful. You could stop there all day long and you would be perfectly right. Another way to write something times itself is that thing squared. Either way, I don't care. But you can consolidate like that if you want to. You can leave it like that if you want to. Either way is fine. Gas. Okay. All right. So let's get into today's stuff. So we're sort of getting into section 6.4. All right, so remind me. I know we just did a bunch of these, but just go with me. Let's see.
$1.
How do I do this?
Find the sum that equals negative 24 and multiply it to 10.
Yeah, find two numbers that make negative 24. You multiply, add to be 10.
Negative 6.
You could think 6 and 4, but
Oh, no, it's not.
you see why not? So some problems are evil. Because 6 and 4 make 10. You're like 6 of them, and your brain goes, yay, we're done. But you got to realize one of them's got to be negative.
Yeah.
Either that one or that one, and they're going to make a 2 of some kind. That's all they can make.
12 and 2.
12 and 2, yeah. So be really careful about those. There are a couple of those in the homework where there's two options, but you got to realize, do they both have to be the same sign or different signs? That's what tells you. Here they got to be different signs. Which one's going to be positive?
12.
Bigger one. 11. So x plus 12, x minus 2. All right, let's stop there. So that's old news by now. So let me ask you this. We had to find factors of 24 that add to be 10. What if this term is not there? What does that mean?
1.
I like it. All right. I left it wide open, right? So that's correct. That means it's a binomial. But in terms of finding the numbers that work correctly, I need two numbers that multiply by negative 25. And what's in the middle?
0.
0. I love it. They have to multiply to be negative 25 and add to be 0.
One and maybe.
So
Those don't add to be 0.
negative 5 and 5.
Yes. To add to be 0, they actually have to be the same number,
But different signs.
different signs.
Yes,
I love it.
zero.
So what we do, instead of looking at this like this, we make it its own kind of process. We say if there are two terms, it could be squares. Do you see how both of these are squared? That's x squared and that's 5 squared. In which case, it's awesome. Let it be awesome. X squared is x times x. 25 is 5 times 5. Make them different signs and you're golden. Because that's how you make the middle term become 0. Do you guys see that? If there is no middle term, that must mean there's two terms. One thing it could be then is squares. And squares is the ultimate thank God problem. You just cut everything in half. Does it make sense? Why though? Because what happens with the middle term here? Plus 5x, minus 5x. No middle term. It disappeared, canceled. Okay, you guys are like, all right.
And doesn't matter. It's negative, like x negative 5 and x.
Of course, as always, you can write. It doesn't matter. The answer, it doesn't matter what order.
What if it was like x squared plus 20?
All right, cool. I like it. So let me see if you guys get this. What allowed this to work? the middle term must cancel. And the only way that two numbers can add and cancel is if they are opposite signs. The minute these are opposite signs, what are they going to multiply to be? Negative. So the reason I'm allowed to do this problem is the same reason I'm not allowed to do shit to this one. What two numbers multiply to be positive 25 and add to be 0?
Nothing.
5 and 5 make 10. Negative 5 and negative 5 make negative 10. Oh shit. They have to be different signs to work. So you can factor this is what we call a difference of squares. Because again, math people are very creative. There's a minus in squares, difference of squares. And then this one we call, what do you think?
Prime.
This one, yeah, it is prime, but what do we call it? What form is it in? Sum of squares. It's amazing. Remember, we're talking about math people, we're not very creative. So, sum. I keep ragging on my people. Sum of squares. You can never factor a sum of squares unless there's a GCF. So this one is prime is the answer. That's prime. You can't make two numbers multiply be positive and add to be 0. You can't. Not yet anyway. Later in math you'll learn something. But right now we're just dealing with real numbers. Alright, let's do another one that works. Alright, so let's go through all the steps you normally would. Is there a GCF?
No.
No. Then you think, how many terms are there? There's 4 terms grouping.